We have let g of x be the indicated transformation of f of x. Write the rule for g of x. So first it says we have a linear function defined in the table, and then we're doing a reflection across the x-axis. This is kind of nice because it's going to help us review how we come up with the equation of a linear function. So we start with our table. Now, if you remember the slope or the equation of a linear function in slope-intercept form is y equals mx plus b. B is the y-intercept, m is the slope. So that m is our slope. We know our y-intercept is always when x is equal to 0. So our y-intercept is going to be 2. But we need to find our m, which is the slope. To find slope, y2 minus y1 over x2 minus x1. That's y2 and x2. That's x1 and y1. Now I just plug those in and solve. 2 minus 1 over 0 minus negative 1. So it gives me 1 over 0 minus negative 1 is 1. So my slope is just 1. That means my original equation is y equals x plus 2. So all that was to find my original equation. Now I have to find my transformation, which is a reflection across the x-axis. If you remember correctly, when it reflects across the x-axis, what that's going to do is it's going to make all of my y's negative, which means that I'm going to take this entire equation. Let's undo those. I'm going to take this entire equation and make it negative. If I distribute my negative here, that's y equals negative x minus 2. And that's my final equation. If I open up Desmos, opening Desmos, I can now log in. As soon as I stop drawing lines here. There we go. And log right in with Google. Then click Graphing Calculator. And I can graph my two equations. Y equals x plus 2. And now I can do y equals negative x minus 2. And so if I look at this, this line is reflected downwards across the x-axis. So what was going up is now flipped down. What was down is now flipped up. So my equation is correct. Unfortunately, those are not the only types of stretches, or only type of transformations. We have the stretches, as I let out a big stretch right there, and compressions. Horizontal stretch and compression by a factor of b. Let me get this out of the way so we can see that a little more clearly. Here the input value changes. So whatever's going into my function, I'm going to change by doing 1 over b. So if the number is greater than 1, it's going into b, then it stretches away from the y-axis. In other words, if this ends up being a fraction in here, that is smaller than 1, then it's going to stretch away from the y-axis. If the number is between 0 and 1, it's going to go towards the y-axis or compress it. You'll notice when it's a horizontal stretch and compression that my point on the y never changes. Where it's 0, when x is 0, there's my y here. That point is never going to change. It's going to stay in the same spot. They're both going to come, both lines are going to come through the same y. When it's a vertical stretch or compression, you're going to notice that this point is going to stay on the x-axis, and they're both going to come through that point. So that's our difference between horizontal and vertical. If I'm doing a vertical stretch by a factor of a, that means that I'm going to multiply the entire equation by whatever a is. As long as a is greater than 1, it's going to stretch away from the x-axis, and when a is between 0 and 1, or less than 1, it's going to compress toward the x-axis. These lines in here mean the absolute value, which means that if this is a negative number, it's not going to make a difference. It's still going to end up being a positive. Now, if I was to start with an equation and say that my first equation is y equals let's go 6x plus 4, and I said it was a horizontal stretch by 2. What that means is whenever I have an x now, wherever my x is, I plug a 2 in for my fraction. So it's going to be 6 times, and then it's 1 over whatever my horizontal stretch factor is, 2x, and then plus 4. See, it's only happening inside of here. 1/2 of 6 gives me 3x plus 4, and I'm done. That's my horizontal stretch. If I had had the same equation over here, y equals 6x plus 4, and I said it was a vertical stretch, by a factor of 2, that would mean that I would take this equation and become y equals 2 times 6x plus 4. Distribute my 2 to both terms. That becomes y equals 12x plus 8. That would be my new equation. What if it had said a horizontal compression by 2? So then if this was a compression, then that means whenever I do this, it's going to be y equals 6 times, and then it's going to be 1 over 1/2, which basically means that that's going to become 2. So this would just be a 2 in here. So it gives me y equals 12x plus 4. That's going to give me a horizontal compression. So it's important to remember that if I'm doing a horizontal, it's a compression if this is a number greater than 1. It's a stretch if it's a number less than 1. And it's the opposite for vertical. It's a stretch if the number that we are doing out in front here is more than 1, and it's a compression if it's less than 1. Sorry about that. Okay, let g of x be a horizontal compression of f of x equals 2x minus 1 by a factor of 1/3. Write the rule for g of x and graph the function. I want you to try this on your own first. So here we have g of x equals, then our original function was 2x minus 1. It says it's a compression by a factor of 1/3. So I can flip this because it's a compression, and that's going to be 3x because it's 1 over 1/3. And then minus 1. 2 times 3x gives me 6x minus 1. And that's my final answer. G of x equals 6x minus 1. I can now graph that. What was our original? Was 2x minus 1. And then 6x minus 1. Now you'll notice that the green line is out further. It goes further right and left than the purple line. The purple line is our compressed form. They both go through the same y point on the y-axis. So that's how we can really tell that it's a horizontal compression or horizontal stretch, is because they're going through the same point on the y-axis. Now we're going to do a vertical compression of f of x equals 3x plus 2 by a factor of 1/4. Write the rule for g of x and graph the function. So you should be trying this and seeing if you can do it. Okay, g of x is going to be, it says a vertical compression. That means we're going to leave this as 1/4. We don't flip it. We only do that with horizontal. We'll flip whatever's in there. So we're going to leave it as 1/4, and it gets multiplied by the whole thing because it's a vertical compression. So distribute my 1/4. That gives me 3/4 x plus, and then 2 times 1 is 2 over 4. 2 over 4 reduces to 1/2. I can now put those two in Desmos. My original was 3x plus 2. And then my second one was 3/4, just the over button, x plus 1/2. If I look at this, they're both going through the x-axis at the same point, right there. So I know that that part is correct. And then that tells me that it's a vertical compression. And then if I look at my original function, it's this one, and it's being pushed down towards the x-axis. So I know that that is correct. We also know that we're not just going to do one of these. We're going to do multiple types of transformations, all in the same problem. So what that means is I should start by following the instructions word for word in the order that it's written. This one says let g of x be a vertical shift of f of x equals x down 2 units followed by a vertical stretch by a factor of 5. I have to do it in that order or it will give me the wrong answer. So I start with f of x equals x. And then in order to create g of x, it says a vertical shift down 2 units, which means I do x minus 2, followed by a vertical stretch by a factor of 5. Since it's vertical, it means it gets multiplied by the whole thing. It's a stretch, which means I leave this number the same. And so it's 5 times x minus 2. Distribute my 5 to both terms. 5x minus 10. And that is my rule for g of x. If I had done it in the reverse order, you'll see how it messes it up. If I'd started with a vertical stretch, that would give me 5x, and then done minus 2 to go down 2 units. That is not correct because I did it in the wrong order. Make sure you're doing it in the order that it tells you to. Okay, this is usually a difficult section for people, which means that I want you to come on Google Meet if you need help. Absolutely should get on there if you need help. Okay, I'll give you your assignment tonight.